right, we're going to take a look at letter C. Let me just close this real quick. All right, so you made your table, and this one has a maximum of 0. So we're going to do an open circle at 0. This one has, it says it can be equal to 0. We'll talk about that in a second. So right now, supposedly it can have an open or a closed circle there. And then up to 3, but not including 3. So we have an open circle there. And then for our next piece, it says x is greater than or equal to 3. So because of the greater than or equal to, I should have a closed circle there. And then this one's going to have an arrow because it doesn't have an upper bound. This one should have an arrow because it doesn't have a lower bound. So I'm making sure that when I plot this, I have arrows where I should, open circles and closed circles where I should. Even before I start my table, I can do that. So the first function is not too bad. You put it in your graphing calculator. You have -2 math absolute value of x plus 2. We expect the V shape. It's going to, its vertex, if we want to call it that, is going to be at -2, 0. But I don't have to worry about that. Well, I do have to worry about that, but it's going to come up here anyhow. So my table is -8, -4, 0, -4. So now I'm going to go plot those points. I've got -6, -8, -4, -4, -2, 0, and 0, -4, and I have to put an open circle there at 0, -4. I can connect these. We see the V shape that we expect at the upside down V since it's got a negative lead coefficient. We connect our points. There's the first piece of our graph. It keeps going down and to the left based on those points. That one shouldn't have given you too many problems. But the next one may have. This function 2 over x can give you some problems because it has some domain restrictions, right? Based on that, what can't x be? X can't be 0. In fact, that's going to give us a vertical asymptote. Some of you could see that on the graph. So even though they told us that it could equal it, it's not going to. It is undefined. It is a vertical asymptote. Now, not all undefined values in a rational function are vertical asymptotes, but if it only came from the denominator, then it is. Okay, we'll talk about some of the other types as we go on. Some of them have holes. If you have a factor that cancels out in the numerator and denominator. So now I have this. I'm still going to put this function in my calculator. I've got 2 over x. 0, you can see 0 is undefined. 1, 2, 3. So I've got 2, 1, and then 0.6 repeated is, does anybody know what fraction it is? 2/3. But if you didn't, you could convert to fraction. It's not going to let us. I could put 3 into the function 2. Well, it is even there. Put it in 2/3. So yeah, we've got undefined, 2, 1, and 2/3. So we're going to plot those. We have 0 as undefined. It's actually a vertical asymptote, so we do a dashed line on that to show that that there's no value of x there. We would have still had a value of x here from the previous if it had been shaded in, but it's not. So now I have 1, 2, 2, 1, and 3 is 2/3, and it ends there with an open circle. Mine doesn't look so open, but it's supposed to be an open circle. And the graph, 0.5 has a value, so does 0.1. It just gets close to that vertical asymptote but never touches it, if you remember that from Algebra 2. So there's our second piece. Our third piece is a square root function. Again, we will have some restrictions. X minus 2, since it's under the radical, has to be greater than or equal to 0 on our domain. When I add 2 to both sides, x has to be greater than or equal to 2, which we're okay because we're not starting until 3. So it's okay. So we're going to plug into our calculator into the y equals the square root of x minus 2. Oh, I forgot the plus 1. Plus 1, because that'll shift it up. And then we plug in the numbers 3, 4, 5, 6, and 10. This gives me 1.4, 1.7. This is roughly 2, 2.2, and 3. So I'm going to plot those. Is that what you guys got too? Or no? Yeah. Okay. So 3, I have 1.4. I felt like it was higher than that. I must have plugged it in wrong last time. 4 is 1.7. 5 is 2. 6 is 2.2. And 10 is 3. So it kind of curves upward. And it starts here, and we have an arrow at the end at 10, 3. And at 3, 1.4, we have a solid dot. Yes?
I didn't, when I plugged in, I got 3 as, like, x3 as 2.
Okay, I think it is.
You put the +1 under the radical.
Oh, that's why. Thank you. +1 should have been outside the radical. So this should actually be up higher. This should start at 2. I'm just going to shift them all up just a hair. And then that makes this, that makes the 10 3.8. 3.8. So it's going to do, it's still going to have the same trend, but it's going to start at 3. I'm not going to have to worry too much when I go to do my range. I mean, I messed it up. That's not good. But not going to have to worry too much when I do my range because the other function is going to cover it. We'll see that in a second. Yeah, it was under the radical. All right. So now I'm going to look at my domain. Looking at our domain from left to right, I'm checking by folding my paper. I've got, it goes on infinitely, so I have negative infinity over here. Does it go on infinitely to the right?
No.
Well, we have this function, right? Because of this, if I look here, yep, there's an arrow there. It goes infinitely to the right. So I know that there's no absolute restriction for a max, no absolute minimum restriction. But there could be some gaps or stuff in here, so I got to look. Every value of x as I go across is good all the way up to 2, all the way up until when? 0. When I hit 0, we have this down here, which is a hole. There's nothing there. It's an open circle. And the other piece of the graph never touches that vertical asymptote. So we already know right here, this was just for this piece that x didn't equal 0, but for no pieces does x equal 0. So we have, going left to right, x does not equal 0 on any part of any graph. Then I keep going to the right. There's an x value here. All of these have x values, even though there's a gap, an open circle here. There's a closed circle above, all the way on. So the only interruption that keeps this from being all real numbers is this vertical asymptote. So our domain for this function will have 2 intervals, negative infinity up to, and not including 0, joined with anything immediately past 0 but not including 0 up to infinity. Any questions on finding the domain for that piece? As I look for the range, I can fold my paper this way. Hey, look, it's going to go down forever. Hey, look, it's going to go up forever. There's no minimum or maximum, absolute minimum or maximum, but I have to look and see if there's any vertical gaps in the graph. If you look, every one of these y's is good. Hey, that didn't have a point, but this does, so we're good there. All of this is good right up until I hit that last point right there. I need to pay attention to that point. That's a height of 0. Y equals 0 is where it stops. So this lower part of the graph went from negative infinity up to 0. And then where does it start again? At that blue point, which if you look, yep, look on your graph, it's 2/3. It starts here, and it's not equal to 2/3. And then it does keep going up from there. Everything has a point from there on both the blue graph and on the red graph over here. So our range is a little different. This time, there's no lower bound, but it stops at 0. And it does take on that value because that's a solid dot. So we bracket it. 2/3 was not a solid dot. It was an open circle. We can see that here. So that's going to be a parenthesis. It picks up at 2/3, and then it goes every point above that works for our heights, having a point on the graph. So it's negative infinity to 0 and 2/3 to infinity, or 2/3 to infinity. They're joined together.